Okay, so everyone, just to remind you that we're recording this session so that people can access it later on. Okay, so welcome to paper session 4, which is our very much our intercontinental session, in particular between Europe and Australia. We might be joined by some early rising people in Brazil as well. And yeah, very much looking forward to this. We've got a very packed schedule for this, so I'll proceed straight away. Let me just go back to paper session 4 on my handy program, which is relatively long because it's been a very busy set of paper sessions. So yeah, we're starting off with Martin Koszolko from University of Newcastle, Australia. They're in New South Wales. Martin is talking about live sampling and improvisation in, Martin, you have to help me out, is it ubiquitous? Ubiquitous projects in participatory music performance.
Yes, well, thank you, Brian. So great to join you from Australia, and as indicated by Brian, I'll be attempting to present an artistic performance. When I was sending an abstract initially a few months ago, I was uncertain whether I could make it to participate in the conference in person. So one of my initial proposals was to do a live participatory live performance in person with you, but unfortunately that was not possible. So as an alternative presentation, I have a video recording of performance that I did on July 4th in Warsaw, Poland. So I live in Australia, but originally I am from Poland, so I speak Polish. And when I was performing in Warsaw, I was able to obviously conduct the conversation with the audience in that language. And for that reason, the video that I will present today features English subtitles. The video, just as a brief introduction, is documenting a performance that involves the audience as an active participant in the act of co-creation. And it's divided in 3 sections. The performance is divided in 3 sections. You will see indicators in the video stating which section is happening when, but the sections are as follows. The first one is live sampling, where I come to the audience with an iPad after giving them a question to respond to. And then I capture the responses live, which form a large portion of the performance later on. So I use various processing and sampling and sequencing techniques to incorporate the recordings produced by the audience in the performance. So that's the second stage, the improvised electronic live performance. In that particular case that I'm presenting today, I gave the audience 2 musical interpretations in 2 different styles. One was ambient focused and the other one was more rhythm based electronic music. And at the very end, the audience was invited again to participate and close the participation circle by voting for which of the 2 interpretations was their favorite. So I would love to present it to you and get any feedback on how this kind of performance could be enhanced. I would love to hear your thoughts, your opinions, and see what you think. The original performance was 1 hour long. However, for the purpose of today, I edited it down to about 15.5 minutes. So that's what you will see. Now, I believe the best way to proceed with the presentation is to played a video which I can share as a screen sharing. Hopefully the internet treats us kindly and we will get good quality streaming. However, as Brian just provided, there is also a version, identical version on the conference's YouTube channel. So if you prefer, you can click on the YouTube link provided by Brian and watch the same thing locally without having to pay attention to the Zoom streaming. So again, I would love to get your feedback on this participatory performance and any suggestions for future iterations and improvements. And with that in mind, I will now share the screen. Oh, it looks like it's still disabled, actually, the screen sharing.
Just give me a moment. Unfortunately, I was trying to set it up so default, but it didn't. Anyway, okay, should be good now.
Yep, that seems fine. Okay. So hopefully you can see that video. Could you just confirm if you can see it? Okay. Yeah. All right, great. So I'll mute my mic and I'll play it for about 15.5 minutes.
Ale także będące po prostu obiektem dźwiękowym. Zapraszamy więc na scenę Marcina Koszolko.
Dziękuję bardzo za
Martin, there seems to be a square obscuring part of the video.
Wojtek wspomniał, bardzo bym chciał zaprosić Was, żebyście byli bardziej integralną częścią dźwiękową całości dzisiaj, która polega na tym, że ja bym Was chciał zapytać, czy wolicie działać kolektywnie, czy indywidualnie. Pomyślcie sobie o tym chwilę. I mogą być to Wasze przemyślenia bardzo takie filozoficzne, ale mogą być też to przemyślenia na temat spraw bardzo konkretnych. Może działacie kolektywnie, a może działaliście i może nie podobało Wam się to, a może wręcz przeciwnie, może nie znosicie być w samotności i działać indywidualnie. I Wasze odpowiedzi ja bym chciał zebrać, podejść do Was z iPadem w ręku i nagrać to, co macie do powiedzenia. Mogą być to kilkosekundowe, króciutkie fragmenty Waszych wypowiedzi, czyli prosiłem o coś w miarę zwięzłego i mogą być to bardzo kreatywne wersje odpowiedzi, czyli mogą być to Wasze słowa, ale też mogą być to dźwiękowe interpretacje abstrakcyjne odpowiedzi na to pytanie. I wiem, że nie daję Wam wiele czasu na zastanowienie się nad tym, ale całość występu bardzo zależy na tym, żebyście coś mi powiedzieli w tym temacie. To na początku jest Wasz udział w tym i to, co ja bym chciał później z tym zrobić, to zagrać dwie improwizowane interpretacje muzyczne. Pierwsza bardziej ambientowa, bez elementów rytmiki, a druga z kolei z elementami rytmu. I na końcu samym chciałbym Was poprosić o głosy, czy wolicie tą wersję A, bardziej ambientową, bez rytmu, czy wersję B interpretacji, czyli bardziej rytmiczną. I wtedy byśmy zamknęli to kółko, zaczynając od Was i kończąc na Was, czyli na Waszych głosach właśnie w tej kwestii.
Sorry, Martin.
Chciałbym Wam tylko dać znać właśnie teraz, może żebyście się zastanowili, co możecie powiedzieć w temacie, czy na pytanie kolektywnie, czy indywidualnie.
Sorry, Brian, are you saying something to me?
Yes, Martin. There seems to be some impeding visuals on the screen share. I'm not sure there's some box. I don't know. Is it the Zoom? I think maybe the Zoom stuff at your end, the Zoom windows at your end are coming up as blank screen. I think it's probably a privacy feature, but
is that the same? Is that the same for all of you?
So So what I'm seeing is I'm seeing boxes which are of the size, they could be Zoom windows or various message boxes, and they're coming up as blank squares. Visual, they're getting in the way. Yeah, so that when you're moving is
okay. I might just try again. Also looks like we have, I think, Victor's mic not muted, so I think there is a bit of a spill.
So I'm going to go around and mute a couple of people just to double check. Yeah, here we are.
Okay, well, let me try sharing again. I originally ticked a box to optimize the video, so I'll just untick that box. So was the audio coming through but not video?
The audio was coming through, the video was also coming through, but we just had those boxes getting in the way of parts of it, and obviously we wanted to be able to see.
Right. Okay, well, let's try again.
Yeah.
I'll just rewind a little bit. Is that better?
Fine. Yeah, that's good.
That's fine. Should I just continue from this point? I'm basically explaining to the audience the premise of the performance, what will happen, and very soon I will ask them the question, and after that, this live sampling process will begin. So I'll just continue from this point, and if there's any other issues, please let me know.
Yeah, that's perfect. Thank you.
Rytmu, czy może to wersję B interpretacji, czyli bardziej rytmiczną. I wtedy byśmy zamknęli to kółko, zaczynając od Was i kończąc na Was, czyli na Waszych głosach właśnie w tej kwestii. Tak więc chciałbym Wam, tak, jest pytanie? Chciałbym Wam tylko dać znać właśnie teraz może, żebyście się zastanowili, co możecie mi powiedzieć w temacie, czy na pytanie kolektywnie, czy indywidualnie. Pomyślcie sobie o tym i ja bym chciał, dam wam parę sekund na to i zaraz Was zapytam, kto da mi rękę w górę, że mi coś może w tym temacie powiedzieć. Kto może odpowiedzieć na pytanie kolektywnie czy indywidualnie? Jest jedna ręka, druga, trzecia, czwarta, piąta, szósta, okej. Jest kilka rąk. To jest... Uważajmy na strzykające krzesło. Czy chcieliście coś powiedzieć? Dobrze, nie ma przymusu. No i przedostatnie jeszcze mogę też. Kolektywnie czy indywidualnie? Czy chcesz poczekać jeszcze? Nie, to... Super, takiego mamy głos na indywidualność. I...
Wspaniale, pracuje się indywidualnie, ale kiedy trwa to zbyt długo, to można popaść w horaksyczną malę. I wtedy pracuje się w grupie kolektywnie, ale kiedy trwa to zbyt długo, można popaść niemalże w horaksyczną i wtedy wspaniale pracuje się indywidualnie, ale kiedy trwa to zbyt długo.
Świetnie, bardzo...
Marcin o magii cięcia, montażu, edycji, resamplingu, downsamplingu, można upsamplingu, koncerty, które odbędą się już niedługo, jeszcze w tym tygodniu, na przykład na koncercie finałowym, głos, utworze, którego tytułu nie pamiętam, ale są tytuły koncertów festiwalu. I dotyk, dom, dreszcz i dotyk. Trzy te słowa związane ze sobą.
Nic nie jest czarne ani białe. Nic.
indywidualnie można zbadać inne obszary.
Koszolko, dziękuję bardzo.
To ja bardzo Wam dziękuję. Fajnie, że tak Wam się podobało, ale mam jeszcze pytanie. Czy wersja A, czyli ambientowa, dostaje Wasz głos? To bym prosił, kto daje głos na wersję ambientową jako ich ulubioną wersję? Czekajcie, raz. Okej, to mamy tutaj właściwie większość głosów już widać. A kto daje wersję perkusyjną? Kurczę, jednym głosem przegrywa wersja perkusyjna jednak. Czyli to jest coś, nad czym będę teraz myślał w drodze do Australii. Dlaczego wersja ambientowa? Ale bardzo dobrze to wiedzieć. Słuchajcie, to jest dla mnie bardzo ciekawy eksperyment, jeżeli chodzi o zaangażowanie publiczności i dziękuję bardzo, że braliście w tym udział, bo bardzo bym chciał ten koncept rozwijać dalej i pracować nad tym pytaniem kolektywnie czy indywidualnie. Dziękuję Wam bardzo.
Okay, so that's the video recording. I hope it sounded okay at your end, and I hope the visuals worked as well. As you could see in the final credit, most of the audio was the audio from the video camera. There was a couple of spots where I managed to sync audio from the desk, but that was mostly when the camera was distorted. For the speech part of the video, but it was kind of the live sound of the room that you could hear and see. As you could also see, which I think I forgot to mention at the start, the performance was based on mobile apps and iOS software. So I used 2 iPads and an iPhone for various stages of the performance. The main reason for that type of distribution of equipment was to avoid too many kind of deep dives in the menu and switching multiple apps on a single device, because theoretically that performance could be achieved on a single device, but with a lot more menu diving. So as I mentioned, the main premise was an attempt to engage the audience, and my quick observation is that people really like to hear their samples, especially if they are manipulated quite heavily during the performance. So it's that anticipation that is created during the performance where people think, oh, is that my voice? Is that me who said that? Or maybe that's somebody who was sitting next to me and that was their sample. But essentially that's the presentation. So I think that's it from me, and I would love to hear any feedback, suggestions or questions, of course.
Thank you. So, any questions in the room or online? If you're online, either put some in the chat. The chat seems to be working today. I think that what happened was that I've got a centrally managed laptop now, and IT services had, in fact, put up a message saying, "We will reset Zoom in 15 minutes to apply an update. Save whatever you're doing," which sort of considers a real-time application. That's really helpful. Anyway, so that's what happened yesterday, we believe. Anyway, any questions in the room, first of all, and then online, and we'll go straight to you next. And if you have a question in the room, maybe, most of you are close enough, maybe just edge a little bit closer. So any questions in the room? Gerald, maybe if you move it closer.
Hi, I'm Gerald. So thank you very much for the video. It was quite interesting to see which direction you go on the collaborative part of the music. I was wondering if you have any plan to extend this, like maybe with an online version that people can go anytime and give some feedback or something like that. So in the follow-up of your live concert, do you think that would be interesting to continue as a more online platform that would allow you to get feedback on different pieces?
Do you mean feedback from participants who participated live?
So, I mean, it could be those specific people, but I suppose it could be also open to a more broader audience.
Yeah, that's a good suggestion. And actually, because I put the effort into this video editing process to shrink 1 hour recording into a 15-minute video, I definitely would publish this video after the conference on the YouTube of my own YouTube channel, and I hope to generate some discussion there. But I think what you are suggesting is also interesting. If, for example, I could capture some kind of email details of participants live and then continue feedback generation by engaging with them after the performance, that would be something I would love to try for research purposes. So that's something I haven't done, but I think it's a valuable strategy to try something like that.
And maybe a follow-up question, if you don't mind. How about doing this live performance with people on Zoom? So like you are now, that definitely will have probably a different kind of feedback from the audience, because usually when we are in the room with the performer, there's a bigger impact and we react differently, but through an online platform, that's probably very different. So I was wondering if you have any experience with this kind of things. Even for the musician, it's very different not to see the participant, I guess.
Yeah, so good question, because my main research interest is actually remote music collaboration, and I have done a variety of projects that involved synchronous and asynchronous live performance over the internet. I have to admit, I haven't tried the participatory approach in that scenario. I engaged in live performances with other musicians which were displaced geographically, but I really love that idea. I mean, I guess now the main challenge would be to convince audiences to, after 2 years of, Zoom and lockdown, heavy engagement, to convince people to again listen to music performed online. I think there is a bit of a exhaustion after those 2 years, but I think it's definitely opening up some interesting possibilities. And from the point of view of sampling through Zoom, that's a little bit more work, but could be facilitated as well. So yeah, another great suggestion. I would definitely take a note of this, and I haven't tried this kind of strategy, but I like the suggestion.
Okay, thank you.
Great, thank you both. We've got a question from Conrad Gibbons. I think, Conrad, you're on mic there, are you? Or you can unmute and ask the question yourself if you want.
Oh, there's a question in the comments. Okay, have you tried?
Actually, Conrad's there live on mic now, I think, so you can ask him.
Yeah. I was just asking you, have you tried performing an improvised session using your set with other musicians, or have you just tried it out solo so far?
So that's a great question, because I use similar strategies when working with my students at the University of Newcastle. So when it comes to my own performances, I typically perform solo. However, I have attempted to create a situation or many situations with my student performances where they would perform in bigger groups. And I have to say, this opens up a lot more interesting possibilities. For example, merging non-electronic instrumentation with electronics. When you have multiple people, you can have that kind of division of roles, which is very difficult to achieve for a solo performer. So I think there's a lot to be gained, Konrad, from having bigger groups using live sampling approaches. And I actually, even yesterday, we had a student festival here in Newcastle, and 3 groups of my students performed, and they were groups of 2 to 3 performers, and they could divide roles in multiple ways using electronics on multiple iPads by multiple performers, but also switching iPads, and then performing hybrid sets where, say, there will be someone playing a saxophone and another person playing on the iPad. And the audience engagement is also intensified, I think, because one performer can approach the audience for live samples, another one could already be playing some music at the same time. And it also provides more opportunities for sample editing. When you have multiple performers, one person can spend a little bit more time on editing the recordings, because the other person could be already engaging the audience by performing something else on a separate device. So I can see that this is even more interesting musically, and also more engaging potentially if you have more people involved on the performance side.
So just a question about the previewing that you mentioned there. So would that involve that person perhaps having a specific set of headphones just to preview it before it would be brought into the set or whatever?
That's right. So it is complicated in that sense that the audience is watching you while you are previewing your samples for editing. The benefit of using something very self-contained like the iPads is that they contain microphones, small speakers, and storage and software. So when I'm previewing and doing quick edits before the performance officially starts, I am not connected to the main sound system yet. So I'm listening to this very quietly. And in those more intimate, small performance settings, this is absolutely enough. It's becoming a little bit harder in bigger venues when you have more noise coming from the audience. And in that case, you probably would just need to use headphones, I guess. But my main strategy is not to keep people waiting for too long anyway. So I keep the edits to the bare minimum, mostly trimming the start and ending points of the audio. But because the audience is really waiting for you to start and watching you, you really want to start as soon as possible. And for that reason, you're really rolling with the punches. And I guess that's the beauty of this approach, that you never know what you will get from the audience. So every performance is unique. But at the same time, if you have some technical problems with the recording, there is no way to fix it really anymore. So you kind of have to, again, go with the flow of what you have captured and use it to your best ability.
Yeah, I presume find some section in the sample that, if there's a sort of, noise or clipping issue, yeah, just use the rest of it. Anyway, listen, thanks for that very detailed answers. I'm actually, so that's all we have time for in terms of questions. Great questions too. So many thanks, Martin.
Thank you.
Thank you.
So next up we have Juan Duarte, who's based at Aalto University in Finland. So I'm just going to highlight you. Yeah, and you've already started screen sharing. Excellent. Okay, so atmospheric attunement, weather data sonification with ubiquitous sensor nodes. So please take it away.
Hi, sorry, I will just share again. Hello, everyone. Yeah. Okay. Yes. Thank you for the presentation and thanks for the organizing this. Can you hear me there?
We can hear you. We can see the slides, but they're in presenter mode. I don't know if that's intentional.
Okay.
So if you want to.
Yeah, let's go again. That should do it now. Should be okay, that?
Perfect.
Great, thanks. Right, so we'll present my recent or my ongoing doctoral research, artistic research at Aalto University, and the title of my research work is Atmospheric Attunement. And so I'm trying to work on different approaches to listen to weather data through sonification and using ubiquitous sensor nodes. So I will present an overview first of my research, and then I will go into detail about one specific project that is dealing with these elements. So, well, the start of my research kind of delved into this area of, let's say, the ancient instruments that were able to make us aware of the wind, such as the Aeolian harp. This instrument, credited by Athanasius Kircher was around the Renaissance time in Europe, and these kind of artifacts were able to give a voice to the wind and to the agency of the weather. And curiously, we crafted the side of music and this ability to be played itself by the weather. So I was very interested in this kind of artifacts, and I tried to delve into kind of what's more about this sort of weather measuring devices and what kind of narratives come along with that. So this kind of also brought me closer to the field of ubiquitous computing, and from learning about the deep time of meteorology. So how the science came from kind of like speculative approach to learn more about our surroundings, and perhaps like some rituals of divination were involved as well. Also, this different task of sensing the weather in one side, and on the other side, there is the aspect of predicting weather conditions that kind of came together from the inception of meteorology. I tried to also work in my research. So when I mean this atmospheric attunement, I'm trying to talk about the capacity of becoming familiar with our surroundings and synchronize and become kind of more empathic with the weather, with the natural environment. So, and since my activity or my main focus is on sound, I try to use these different sound devices or instruments that are able to translate weather data or energies into a sort of medium to become familiar. So my hypothesis in this context is that this kind of attunement is built upon three elements that are able to create the listening experience. So the embodiment, so how our body is able to already sense the weather. The situatedness, which I mean the cultural knowledge that are able to create a meaningful experience about the weather. And finally, the technologies that are also kind of mediating or extending our senses into being able to create a sense of our atmosphere. So the project I'm developing recently and presenting this summer in an exhibition in Riga in the gallery called Rixi. It's called Augury. And it's a project that combines like some of the developments that I did before, working with weather sensors, divinatory practices. And okay, I will go into this one. So in this case, in Augury, I employ a semantic approach to sonification. So let's say I'm using weather data that is translated into audible signals that create a meaningful connection between indirect ecological and metaphorical environmental sound categories. That means that I'm using weather data not just as a direct translation of this data into raw signals, but I'm using also as a kind of like a component or a compositional element that is able to represent these ecological environments. So I will go into detail on this later, but so let's say also the notion of Augury is kind of as I said, trying to go deeper, and also I'm writing about this in the article. So the notions of attunement, resonance, and harmony, which are really all dated, talking about like these first ideas of music. So they're kind of like within this deep time of the meteorology. And I'm trying to kind of through new media technologies work around these concepts. So the first artifacts that I found which were relevant and inspired me to work in Augury was these practices of, for example, the parapegmata, which was a device used in ancient Greece and Rome to kind of collect data across not only meteorological events happening on the ground level, but also astral events. So it was sort of like astral meteorological speculation. And these devices were placed in different cities in the ancient Roman Empire. So they were able to kind of collect and anticipate what kind of cycles were happening. Of course, these kind of tools were also kind of used in the context of farming. So people could be able to anticipate when was the right time to do different activities regarding the food crops and so on. No? So, and the other practice that was very interesting for me was the augury, which was related more to this ornithomancy, so the observation of birds and how this kind of agency of the birds as being close to the upper connection with the atmosphere, that were giving a sense of people of there's the seasons, and as well they were used for taking state level matters and in urban planning and warfare. So I thought that this could be like some kind of background also that connected me with my my background as a I'm from Mexico, so I was interested to also connect with this kind of divinatory practices and think about. I found that recently this kind of ritual of divination, it's called the smoking mirror. In Nahuatl is called Tezcatlipoca, and it symbolized the winds and the subconscious. And through observing these obsidian mirrors, the ancient Aztecs were able not only to see their reflection, but also they saw the surroundings reflected in this surface. And this smoking mirror is kind of like kind of a source of inspiration for me to kind of bring an interface that it's able to, again, being able to listen to the environment, to the atmosphere through this weather data, and being immersed into a media experience that I arrange using sound, light, and smoke. So for me, this connection between ancient knowledge and digital technologies is a way to kind of understand our environment in a different way, to kind of diversify our technologies, using the kind of the terms philosopher of technology Yu Hui uses in his work. And I believe that also these kind of weather stations that I'm crafting are a way to symbolize the augury ritual of using birds as emissaries to inform us about weather conditions in distant locations. So my plan is, for example, to use with these weather stations, not only registering data and recording them, but also being able to transmit using long-range transmitters or transreceivers that are kind of placed in different areas where to inform or send data to gallery space. And I found like in this, just like two notions of, in the theoretical field, Catherine Hales talks about ubiquitous computing in this form of sensor receptors, actuators, and even cognitive processes. And I think from her post-humanist approach, I mean, it's important to kind of interface these technologies as environmental sensors that are able to kind of give a sense of vast geographical areas. On the other hand, Mark B. and Hansen talks about the capacity of these technical systems to catalyze the sensation into a finer temporal granularity beyond human capacity. And these systems are able to facilitate the experiential cognition of environmental processes. And I think this case is really relevant for studying atmospheric phenomena beyond our human capacity and our existing senses. So this is kind of like the model I'm using for interaction in this installation. So I have on one part the user interaction, having this mirror and the stones, which are also obsidian pieces. And these objects are connected through a kind of touch sensor and copper traces placed on top of these obsidian artifacts. And these are able to trigger the mist, and the sound part, a multi-channel sound system. And we have on the other side, on the other end, the environmental sensing, the sensors. And well, I'm thinking about using this in the later stage of the installation, using software-defined radio to include also as a weather signal. So I use this kind of like a touch device sensor connected to ESP32, connected to the interface, this obsidian touch devices, which were able to, have a, like the interactive part to the user. So let's talk about the part of the sonic interaction design. And well, I use for prototyping first recorded data, but then into a further final deployment, I would like to work with this real-time data. So using these long-range radio devices that are able to feed in real-time the installation. And well, for the sonification, as I said, I'm trying to use kind of more like metaphorical sounds that are able to kind of resemble, well, storms or wind forces and drone music, which is kind of like the aesthetic that I chose for this project. And I believe like I connect with the field of ubiquitous music, how this could be also an example of ecological grounded creative practices, and wherein sonic ecologies encompass material sources, human agents, and the context where the creativity takes place. So I believe these kind of weather elements are can be artistically composed into this drone music. So kind of like to enhance the ritualistic aspect of becoming in tune with the weather. So that's why I use this kind of sounds, and I will show you at the end a video that kind of presents that experience. So just to go through some details before that, and the data that I was collecting was the wind direction read across 4 points, 4 cardinal points, the temperature, barometric pressure, and dust particle detection. So these sensors were connected to an Arduino Nano and recorded as data that was later informed or connected via OSC protocol to a laptop running pure data. As a sonification, I relied a lot on the ELSE library in pure data and was able to record this offline data, but it's also able to work on the real-time context when I'm able to include the long-range radio transmitters. So I'll go through this kind of waveform granular synthesizers, and as well, the touching part is kind of triggering different sets of days recorded nearby the exhibition space. So we have like six or five different data sets that are like touch sensitive, activated, or triggered by the user. And so the smoke and the light is also changing depending on the touch that happens in that sense. So there's also like a LED array hanging from the installation to create kind of like a circle, magic circle area of interaction. And that is also kind of like at the moment, like a fixed composition that just highlights the difference between these data sets. So now I would like to show you. One more video, which is also kind of complementing that part. Okay, yeah, so just as some kind of remark.
Sorry, Juan, just before you do, just to, you're nearly finishing. I was just about to say you've got about 5 minutes left, or maybe a bit less.
Yeah, I'm about just to give final remarks about this. So, I think like as an experience of this first iteration of the project, I realized that perhaps the touch interaction would be, perhaps I would like to correct this in a way that is not just this immediate or instant interaction, but there's like a possibility to actually just have like a more slow kind of envelope emerging from that kind of touch base, which is, I guess, the problem with instantaneous interaction is that it doesn't really give much room to focus on this part of well, kind of the ritual or becoming kind of focused listening into the work of sonification and the composition behind it. So I believe that there's potential into also crafting also like a bit more complex instrument out of this touch-based interface. So I would like to just have like a perhaps multiple kind of like a matrix that is connected through different parts of the touch sensor, and that it reacts on certain gestures and so on. I'm thinking also, yeah, how to encapsulate all this kind of system within a portable way that is possible to bring it into also kind of like a performance context. And well, I believe that more or less is what I have for you now. And thank you again for your time. And I would like to hear from you, your feedback and comments. Thanks.
Excellent. Really beautiful work and really fascinating ideas, lots of different threads to pick up. I mean, one of the things even that struck me around that question of sort of, yeah, the tyranny of immediacy sometimes in touch-based interactive installations. I mean, that is a challenge, but I know that idea of maybe a looser couple. I'm certainly that's something Gerald, you guys were looking at in your work. So yeah, lots of common threads. Any questions here within the room first? Any questions online? Put them in the chat, and then we'll come to you as well. So in the room first, because I'm looking your direction. Gerald, yeah.
One comment. Yeah, thank you very much. It's very interesting, and I was wondering if you have any intention to extend it in other places. So like having the installation where you are in Aalto, but also like in different places of the world, and which could also allow you for the touch screen not to be reactive on the place where you touch, but on the other side of the world, basically. So that could give a remote interaction between participants without seeing each other. I was wondering if you have any intention to go further on that direction, because you get the data anyway from a remote place. So they could be distributed all around the world on different versions of the installation.
Thank you so much. That's a really interesting question. I believe that it's important first to bring the project elsewhere. I presented this one in Latvia, but I would like to also have the opportunity to bring it soon to other venues and countries. So yeah, I'm working on that. And regarding the part of kind of like remote interaction, that I believe perhaps is I find it a bit maybe like a challenging part, because I believe also that the aspect of rituality is something that needs presence and into perhaps my understanding of like being within this let's say magic circle of the ritual. It's important to kind of experience the work in a physical way, although I'm relying on these remote sensing nodes. But other than that, I believe like kind of the listening experience within my research scope, it has to do a lot with this attentive presence and being connected with the space as well. So in that sense, I would probably kind of keep the work in those lines. But thanks for your comment.
Thank you. Yeah, we've got another one in the room, and then anybody online, please put something in the chat window, and I'll come to you. So yeah.
Yep, Colin here. I didn't see all your presentation, but I did see the last bit about the sonification weather data. And I wondered if you were aware of the World Weather Network.
The World Weather Network. Did you?
Yes, it's another collective of artists who are sonifying climate and weather data from around the world. I've just come back from New Zealand, and I did there see a piece at the Tattoo Gallery in Pakuranga, just outside of Auckland, which had Phil Dadson and Janine Anderson and a number of other artists collaborating. One of the things they had was aeolian harps on the roof of the building, which was then transformed and rendered into the gallery. And then there were other kind of works that were related to climate change and weather, and including some stuff from Antarctica. Yeah, you may be interested to look up the World Weather Network.
Thank you. I will definitely check. I didn't figure them. I mean, I didn't know them. Thanks.
Thank you.
Okay, and next we've got Martin over in Australia. So I'm just going to add a spotlight so we can see you. Hi, Martin.
Hi, and thank you. That was a fascinating project, really interesting, because I'm also very interested in environmental sampling, and you mentioned mobility, which is something that I very much explore as well. But my question is about the idea of interpretation and how you approach interpreting sonically the weather events that you are capturing. And when you showed the video, that was quite interesting because you had additional stimuli in the form of lights and smoke. And I would love to know, I guess, whether that was also coming from the data that you captured. So there's, I guess, two aspects to the question. One, how you translated perhaps the data into those additional stimuli, but also I'm keen to know, how do you make decisions about sonically translating the data into specific sounds, which I guess is connected to how the audience will interpret the weather data that you have captured.
Yes, thank you, Martin. I believe the kind of like the decision for working on the sound design about the data was kind of like rather than giving like a direct or truthful picture of this data, it's rather to shape it into sort of like the cultural knowledge or the cultural cues about this ritual of divination. So I guess the framework of kind of, well, giving sense to all these elements is actually guided by the interpretation that I give also to these ancient rituals of weather divination. That means that although I believe, this Aztec culture is kind of like disappear or disconnected to our present, I believe that technologies are able to kind of bring back and kind of reconnect or re-enhance. So, and the idea of also kind of being in tune with the environment also for me was an opportunity to kind of bring this kind of drone ambient music as a medium to perhaps kind of like focus or underline the environmental or atmospheric elements of music or weather data. So all in all, I believe it's pretty much like a artistic decision, although still relying on these technologies and weather mediums, but it's up to the, I guess, to the ritual or the kind of the concept, how to organize them and how to give them meaning. So that was for me the case. Thanks. I hope I answered your question.
Thank you. I'm just conscious of time. We do have another question from Conrad. What I propose in the interest of time is that, Conrad, if you could put that into the chat window, maybe Juan, you could answer as a sidebar there, if that's okay. Yeah, so much more to talk about here, but I think we'll need to leave it there. So next up, we've got Guido Kramann, who's based at the University of the Applied Arts, Brandenburg, Brandenburg. I'm just going to add a spotlight for you, so we can see you there, and remove spotlight for Juan. So Guido, good morning. How are you doing?
Yeah, hello, Brian. Hello, everybody. Can you hear me?
Yep, very clear.
Okay.
Thank you.
And can you see me? I have no video at the moment.
Yeah, we can see you.
Okay, so it's not in the other direction. Okay, I have some slides. Should I share the screen or I send it to you?
I think you can share the screen. I've got that as a backup, but if you share the screen, I think initially.
Okay, I will try to. It doesn't work.
Is it easier for me to share at this end?
Yeah.
Hold on a second. I'm just loading yours now. I mean the only I can share the screen. The only thing is you'll need to just rely on me to move it along. So if you're happy,
okay, I can share the here the slide.
Okay.
Is it there?
Yeah.
Okay, so I will start. Okay. Yeah, my name is Guido Kramann. I'm from University of Applied Sciences in Brandenburg, Germany. And I'm dealing with symbols and representing music with symbolic things here. Okay, to give an introduction, when I want to write a new generative algorithm for producing music from scratch, let's say in the Java programming language, I'm initially faced with nothing. This is because nothing in the available commands of this general object-oriented language has any relation to composing music. This circumstance is good and bad at the same time. Good is that the danger is small to fall into familiar patterns by using familiar structures again. Bad, on the other hand, is that little spontaneity is possible here because the development process is long and cumbersome. In addition, with some project, I get stuck at a stage that doesn't yet have the complexity and simultaneous stringency on the musical side that one expects in good music, while the associated software side is already hopelessly convolved and overcomplex. In addition, the whole thing described so far is purely private matter, where it is difficult or impossible to make third parties understand what one is doing. The subject of this contribution is now to present the consequences, recognitions and experiences that have arisen during the transition of the working approach just described to the use of a self-developed symbolic generative script language. I would like to summarize these in the following, but first, the generative symbolic scripting language AOGscript, AOG stands for Arithmetic Operation Grammar, which I developed is suitable for live coding. You can change code in real time and immediately hear an effect. Basically, it is about controlling a virtual musical instrument and thus bringing the composition directly to the ear, for which the term improvisation was become common in the context of ubiquitous music. Especially, I reduced my work to control MIDI. Yeah. Okay. Consequences. It is one thing to write generative software for creating music, but quite another to present the ideas it contains in a way that is comprehensible to third parties. See figure 1A. For third parties, such a program is typically a black box. To address this issue, parameters from the software that essentially determine the generated musical shape could be extracted. See figure 1B. At least this way, the result can be influenced effectively and a user can learn something about the meaning of these parameters for the shape of the generated music via this feedback. Providing access to parameters via sensor-based human-machine interface could be interpreted as an implementation of this principle. Going further, in this direction, parts of the software can be influenced by script parts by implementing so-called modding. In this case, the structure of the scripts can then already represent a part of the generative principles underlying the software. See figure 1c. Modding has existed since the start of computer music and got very famous in game development, like for Minecraft. Finally, the original software can be taken a backseat to the script parts, and the script becomes an independent language that can be described to third parties independently of the interpreter behind it. See figure 1d. Even though in C-Sound Pure Data, Max MSP, and Faust, the source code is typically compiled and not interpreted, they detach from the underlying programming layer in the way meant here. The language provides specific language elements suitable for music production, and they serve as a basis for many projects in computational music, and more specifically in ubiquitous music. If one comes up to this point, then this has the enormous advantage that the script has representation character in relation to the generated piece of music. This means knowing the script is sufficient to be able to reproduce the piece of music. The language elements of the script are then very powerful, or what is the same, slight variations of the linguistic expression that can be formed with them result in significant law-like changes of the musical shape. In other words, the linguistic expressions are very sensitive to the musical form. This is accompanied by a further advantage. The user can quickly learn to implement musical ideas with the help of the quick successive additions and changes to such a script with continuous automatic conversion into music. This also makes the system suitable for live performances. Okay, main findings. If it is possible to formulate adaptive, supplementary and/or intelligent behavior as an algorithm or at a higher level as abstraction, as lines of code in a script language, then the user has been given a language that can show him the possible actions with the instrument immediately at a stroke. Why that? Well, because the formulated algorithm, and to an even greater extent, the present special script points beyond itself to all the variants and alternatives that would also be possible in its place. While a musical instrument in front of one is only what it is, algorithms and scripts are not only symbolic representations of a special aspect of the instrument or of a composition, but here someone has already brought the special expression into a larger context by the use of the language alone, and thus conveys a multiplicity of possibilities of action, which empowers the user to operate improvisation himself and independently, or to develop adaptive, complementary and/or intelligent musical instruments himself. This empowerment of the user is taken to the extreme by a purely symbol-based scripting language like AOGscript, while in languages like C-Sound Pure Data or Faust, the representation of music is on a variety of levels, such as words, menus, cables, or icons on the one hand, or abstract representations such as variables, parameters, and functions on the other. In AOGscript, it lies almost exclusively at the level of one script itself. Okay, I would like to give some sound and how a sound is a formula is converted into sound at a simple example and also some more complex examples. To do this, I suggest you to hold on a minute and take a link I give you in the chat and play the example there. maybe it's the best way. This one here also visualize what I will explain next. Oh, okay, I have to stop sharing the script. No, I do not. I will first explain something here before the example. Okay, here, look at these lines. Oh, I have it here in my slide. You see here not many symbols, so it doesn't take long to explain them. Let's start with these brackets here. Okay, I made up a special scripting language using the natural numbers as a basis. And this hyphen here is a counter. It counts 0, 1, 2, 3, 4, 5 in the tempo which is set up. This underline here is an unary operator which will take into account from the counting 1, 2, 3, 4, 5 only prime factors of 2, 3, 5, and 7, and throw away the rest of a number. So if you have the number 12, everything will pass through. And if you have, let's say 11 times 12, only 12 again appears after this operation. It is because I see something musical in the small prime factors in the natural numbers, and I would say I'm able to produce music by converting these natural numbers in the way with special operations I made up. So then here comes a division. It's just a normal division, except of the fact if something doesn't work, it will set to 0 and nothing will sound. And anytime when by this division something comes out which is in the range of a playable frequency of an instrument, this frequency will be mapped to a tempered scale and played by an instrument. So this is a kind of hello world example of this script language. And now I will stop sharing and give you the link to where you can hear it for just 2 minutes. It needn't be a long time. So it is this YouTube video, Sound of N. And I send it here. And okay, I can share again and show you how to reach it. Here you can see it in my document. And there is an easier accessible link where you only hear the sound. So please take your time and have a look to it for 1 or 2 minutes.
Guido, I'm just conscious of time. We've got about 5 minutes left for the presentation.
Okay. Yes.
So does that work with us taking 2 minutes to look at this? Or maybe what might work better is, I know you've got the QR code on the slide, so perhaps people in the room and at home can just scan the QR code, play the example in the background, and then maybe you can talk on. Would that work?
Okay, then you can have a look to it later. Okay, are my slides now visible?
At the moment, no, we've just got your list of links.
Okay, then I have to change it again. Now?
Yep, very good.
Okay, so some further hints. Okay, instead of presenting further examples, I would like to list some of the most recent compositions. You can get them also in my paper. So, conclusions. If it's possible to formulate adaptive, supplementary and/or intelligent behavior as an algorithm or at a higher level of abstraction as lines of code in a script language, then the user has been given a language that can show him the possible actions with the instrument immediately at a stroke. Why that way? Because the formulated algorithm and to an even greater extent the present special script points bind itself to all the variants and alternative that would be possible in its place. And I extended it now also with binary operations, which are able to handle time stretching and phase shifting and repetitions. And in the actual version, it's also possible to formulate directly in the script commands with MIDI, which also directly have effect. And it is made up in a way that it's just a text file where you type in something, save it again, and my software will repeatedly load the script every tick, of course, which is the shortest time unit in the performance, and adapt the changes. Okay. However, the endeavor to lift everything relevant for the description of the generation of a piece of music onto the symbol level always goes hand in hand with a certain limitation of the creative possibilities, and also with a certain implicit normative definition of what counts as music. Here one has to decide individually whether the advantages outweigh the disadvantages in the particular application. But of course, it's possible to add more and more operations. And at the moment, I'm working with a disc clavier and using also a symbolic representation for getting the input of the MIDI data of this piano and calculate with it in my script and produce new things which are influenced by it. So it goes more and more in direction of real life performances where, let's say, lay people also are able to, let's say, big piano concerts where they play simple things which control then the script, and the script will make up more complex tasks. And here are some links for scores and recorded music, which and in the scores at the beginning there always is listed my symbol language to have a relation to how many symbols are necessary to produce music coming later. And of course, in my paper, I describe in detail this language, what doesn't make sense now in my presentation. So thank you very much for your attention. Are there any questions?
Well, Guido, I'm just thinking that we're actually okay for time for about 3 minutes if you do want to play one example.
Okay.
Maybe one of the later ones.
The more complex ones.
Yeah, the ones that give a better sense of the guitar system.
Yes. So I would take the one you see here in the slide, and I can pass the YouTube link and the PDF link down in the chat now. Yeah, and then I will share it again here.
And I can share I can share from YouTube now. Great. Let me just see if I can.
This is more complex.
Okay. Just bear with me 1 second. I'll just see if we can get this.
Here.
Hold on a sec. Okay, right. Give me 1 second then. I just need to share screen. Share sound. So can everyone see this and hear this?
This is not so complex. So it was a simple example, it was not a complex one, but don't mind. Okay, this was a simple example, but it was the first trial using the Disklavier just as an input and making some calculations with my script and giving a produce from this. Then what is the machine doing? Yes, let's say. And okay, I just I can I could share this here again, which is the script doing what you heard. So the letter Y gets the upper voice of what I'm playing, the letter Z, the lower one, and this means this interval I'm playing is put every time the upper tone where the Y and where the Z, the lower tone. And then there are some calculations. For example, I take this a division by 4 or something to change the tone, or I make with this add 2 means a time stretch. So the higher voice is slower playing and reproducing a transformed voice of what I was playing. And the letter P means a delay of the tone in a number of ticks. So while I was playing an interval, you hear the kind of phrases as answer from the machine, and this can be was made especially by these time shifts. So it's a very cryptic language, I must say, but it's a very powerful at the same time, as any operation is only of one character, and so it can be changed very fast and during working with it. And this is and it makes a very compact visual impression. Yeah, and this E sends it as a MIDI MIDI tone to the instrument, whereas what is here in hyphens are some parameters for the MIDI instrument. Yeah. Added, and any parameter can be feeded by the result of one line which is calculated. Okay, this was the presentation. Yeah. Thank you for your attention. Yeah. So I come back to.
Thank you, Guido. Really impressive, and I would say maybe terse and elegant rather than cryptic. Really, I mean, I think that when you explain it, the compactness does help. I'm going to throw it open to the floor. Any questions from online or in the room? We'll maybe go to online first, just to see if there's anyone there, because I know we've had quite a few questions in the room. Any questions online first? Okay, maybe we'll go back to in the room and we'll come back to online. Any questions in the room? Victor, very good. Do you want to come up a little bit closer to the front, just on account of the mic? Thank you.
Okay. Hi, Guido. Really interesting. What I wanted to know is, are there any plans for moving this away from MIDI? Because MIDI has a lot of limitations. It's very
I'm thinking always about this. On one hand, okay, the disadvantage, of course, is the limitation what I can do on the level of my script language. But by MIDI, I give it a good interface, which is easy to deal with. And last thing, I was starting transferring things to a web-based design, and there I try to make a physical modeling program with JavaScript. It was not possible, I would say, at the end, because of the slowness of JavaScript, and so I got back to MIDI because this is better for web applications. If you say, okay, you have to have some instrument, and okay, it was a first limit to limit it to this. I could concentrate more on representing musical structure instead of sound. And of course, it's more about musical structure than sound. And what you heard was just something very simple. I'm making very complex musical pieces. You could see in the other examples, which would be too much, I would say, if there would also be represented all the parameters of controlling sound. But of course, I can do it in the limitations of MIDI to control the pedals, for example, of the piano and so on.
Thank you. We've got a question from Martin, so I'm going to ask you to unmute, Martin. I'm going to add a spotlight to you.
Oh, great. Thank you. And thank you for your presentation, Guido. My question is on whether you have attempted to analyze the musical outcomes produced by your process in relation to existing musical traditions, perhaps how your outcomes relate or not relate to other existing musical styles and compositional approaches.
Yes. Okay. Thank you for the question. Yes, of course. My first research was finding, let's say, musical structures in natural numbers. This means there is a correlation between if you look as the difference in prime factors of two numbers as a kind of degree of dissonance. You can see similarities to classical music, of course, about the distribution of dissonant and consonant sounds. So that in, let's say, in classical choir or orchestra music, dissonances are typically not a bit far away from each other, and consonances may follow one after the other. From this starting point, I developed some transformations of the basic row, and also I made some trials to compare, for example, what about counterpoint rules or and classical harmonic rules in comparison. But I didn't want to just adapt classical music style directly with this work. For the reason I would like to make something new with it, and I really want to see what is the difference to what this type produces compared to classical music. So I'm stick a bit to classical music, what is the style, but it's maybe not so much the potential of my script language the reason, but my personal taste, let's say, also. I told before that I could map, or I map the frequencies to a tempered scale. This, of course, gives the impression of classical music. I could map it also to pentatonic scale or to microtonal scale. I tried out this. I have some examples for it, but I prefer using the scale I'm used to. Yeah, but there are variants of styles possible, but in the context of music which has defined pitches, I could say.
Okay, thank you. We'll have to move on, but many thanks, Guido.
Okay, thank you very much.
Great discussion. So next up, we've got Joshua Daniel. Sorry, hold on a second. I need to just bring your name up and forgive me. Joshua Daniel Muthu Chaiphas. Is that anywhere near your name? Apologies.
Yeah, that's right.
And you're based down the road at Maynooth University. So let me just put a spotlight on you as well. And I'm just going to remove the spotlight for Guido. So you're most welcome this morning. And you're presenting on Auralization of room acoustics using binaural impulse response. And we can see your slides, and that's all good. Okay. So yeah, please take it away.
All right. Thank you so much. It's good to see everyone here. My name is Joshua, and I'm a master's student at Maynooth University in the music department in Ireland. So today I'll be presenting on the topic of auralization of room acoustics using binaural impulse response. So before I start, I want to acknowledge Dr. Ian and Professor Victor for all their help in this project. It's good to see them here in the room as well. Yeah, so in audio engineering, music production, or even performance, it's often required. We need a specific acoustic environment to play back the sound in a efficient manner, especially when it comes to multi-channel, where a multiple number of speakers are involved. It is physically difficult to carry around the speakers or the physical space. So it is time consuming, also it's not very cost effective. So we use binaural technologies in order to address this. Binaural method basically replicates sound as heard from human ears. So we capture binaural impulse response of the room, and using convolution, we can emulate the room in accordance with the microphone that we use to capture the impulse response. So this project aims to develop a software for auralizing room acoustics. In this case, octophonic room in Maynooth University. So the octophonic room is basically the listener will be at the center where 8 speakers will be around the listener. And the project aims to develop a software where the user can load their own audio into this room and listen to individual speakers using the software system. So for the first step is to capture the binaural impulse response of the room. So to do this, we use a special kind of microphone, a dummy head microphone. So this microphone is usually shaped, modeled in the shape of human head, where the time difference between 2 ears or the level difference, or also the reflection around the pinnae, all taken into consideration, giving us a representation as if it was heard from real ears of humans. So the process of capturing begins by putting the microphone in the center or the listener's position or the sweet spot of the room. A sine sweep of 20 to 20 kilohertz is played over to capture the impulse response. So this was done for individual speakers, so 8 speakers plus a subwoofer. So so from the speaker 1, 20 to 20 kilohertz sine sweep is played and captured likewise for all the 8 speakers. That is repeated to get individual impulse response. So now that we have the impulse response ready, I mean, once recorded, I have put it into a DAW to just cut down and align it. And once the impulse response is ready, it's time to build the software system where this was the basic flow of the system, where it takes an input and goes through a routing matrix where it determines if it's mono, stereo, or octophonic, and goes through processing where you can add a time delay, delay compensation and other processing. And it is then convoluted with the impulse response that has been captured. And it is mixed down to a binaural and then can be listened using the headphones. This was developed using C Sound and Cabbage due to its ease of use and flexibility and power. So this is how the software looks. This was completely developed using C Sound and Cabbage, and the skin is basically designed using Photoshop. So as you can see, there are like 8 knobs around here. So each represent a speaker in the octophonic room, which can be controlled individually, and the listener's position is at the center. And the masters levels control the overall levels of all the speakers, and there are metering to identify sound is coming from which speaker in the room. You can load your file, play and stop it. This currently supports mono, stereo, and octophonic files. So the listen to source option here basically lets you listen to the song or the sound that you're loading into the system before convoluting. So you can compare it side by side. You can listen to mono and stereo sound by enabling and this particular button. So once it's developed, we ran listening experiments. The experiment involved a group of 7 participants. It included musicians, non-musicians, and also a participant with hearing impairment. So a snare sound was loaded into the system that we developed and convoluted using the impulse response that have been captured and was played back 10 times in different speakers in random way. And participants were instructed to wear headphones to monitor it. And a spreadsheet like this was given. So it can be marked what the participant was saying. And these were the result of it. So the results demonstrated all the participants, including the one with a hearing impairment subject, were able to localize more than 5 sound. So localization for French speaker were consistent among participants, all 3 different categories. However, participants, especially non-musicians, found it difficult or took some extra time to localize sound coming from the rear. Yeah, so this was a result. So the practical applications of this software is obviously musical application where a composer or a musician can reference his or her song without having be able to present in that particular room. They can listen to multiple speaker and monitor surround sound. Also for performance venues, for example, if there is a concert happening, the organizer can just capture the impulse response and send over to the performers. So the performers, even before coming to the venue, will have an idea how their song is gonna sound in that particular venue, considering all the reverb issues and all the other issues. It can be also used in post-production and film production for referencing and monitoring in different speakers. Can be used in education and research as well to teach about room acoustics and also to research about different rooms as well. And also can be used in virtual reality application as well. And the limitation is very obvious. So every human have a different size of head and a different shape of ears and different torso. So so it is not possible to take one impulse response that is suitable for everyone. So the individualistic is missing. So listeners' variability is present. So the accuracy is definitely changed. And this system is highly headphone dependent. So it can be monitored only using headphone. Excuse me. So also in a real environment, when the listener is sitting in a room, it is natural to move his or her head around. But in the system, the listener's position is fixed. And also the low frequency accuracy is not as good as being physically present. Also the vibrations to our body and the desk and the objects will be missed in this. Excuse me. So the future works involves adding an headphone calibration at the end of the flow. Since it is highly headphone dependent, it is important to have an headphone calibration which can. So the idea is to measure multiple commonly used headphones, and then use it to calibrate to get a more accurate response. and also to have a plugin and standalone version. And the future work also includes to add more audio format, maybe ambisonic as well, and hit tracking. Excuse me.
Joshua, thank you very much.
Can be. I've been recently working on head.
Sorry, hello.
Oh, yeah. Am I audible?
Yeah, you're on. Yeah, we can hear you.
Yeah. Sorry about that. I think internet got disconnected. Just the last side. I've also recently been working on head tracking for the same. I've been studying the crossover between different speaker to move around, and also have an idea to add more rooms in the future. Also added a MIDI controller option now, so the users can diffuse their song, using the software. So yeah, that's it. Thank you.
Nice, thank you.
No, that was a very quick one, though.
Very, very nice implementation. We're going to go straight to questions. Are there any questions from the floor or online? Yes, we're online. Have we got questions? Anybody in the room? Yes, Alex, could you move just a little bit?
Hi, Joshua. Yeah, thanks for the presentation. Very exciting project. I think this can be very useful for a lot of people. I think I have to look into this that you see. It can be useful for many people, and especially in the format that you're providing it. It looks like a VST plugin or something. That is really great. I was wondering a bit about the listening study you were doing, because I was expecting to see a significant difference between the hearing impaired person and kind of the experts, but to me it looked a little bit like there was not that much of a difference. So I was wondering, what did you count as correct and what is not correct? Did they really have to say speaker 2 or speaker 1, or was it just the direction? Or maybe you can elaborate a bit more on that.
So the participants were asked to point. So a picture of the layout was shown to the participant before starting the experiment. So the participant should mark which the sound is coming from, which speaker, and that was the result. I think one more experiment with different rooms, if it's involved, I think it will be better to get a more accurate result, to provide a better finding on that.
Okay, thanks.
Any other questions? I might ask just a quick follow-up to Alex's question, just about the nature of the hearing impairment. So you mentioned, one of the subjects was hearing impaired. Obviously, they performed comparatively well around this. So, what was the nature of the hearing impairment? What was it? A very sort of,
So the subject hearing capacity in 1 year is down by 60%. So she cannot hear 60% in 1 year, and 1 year is good.
Okay. So that's interesting. So even quite robust with significant changes in 1 year. Interesting. Any sense? I mean, obviously you had very broadband materials through the snare. Did you do any more informal tests with any other sort of narrower band sources or things like that? Did you try anything else and see how the participants?
I've personally sat inside the room and compared it with actual listening and headphones by playing different music.
I mean, in terms of the participants, though, I know you've only spoken about the using the snare sound, but did you try anything with other musical sources, more informally?
I also played some synthesizer sounds while testing, but not for the participants in this test. but informally, I've tried that as well.
Yeah. No, I suppose it'd be interesting to see how the participants, relate to more sort of, narrowband sort of musical sources, particularly the one with the hearing impairment. But yeah, it's quite interesting they perform so well. Any other questions?
Yeah, maybe also on this experiment once more, because I was briefly looking into the paper and you kind of report very raw data there, kind of the table with how many correct and not. So if you kind of pursue research in that direction, I think you could kind of design the study a little more in a way that you can really run statistics on it in the end to kind of really report about significant differences between the stimuli, as Brian suggested, or between groups of participants or something like that. You probably need a few more than 8, I think you had so far, maybe something like 20, 30, but I think it could be a really interesting study in the end. So if you follow that road,
well worth following up, definitely. Okay, any last questions? Any questions online? Going once, going twice? Okay, that's you, Joshua. Thanks very much for joining us this morning.
Thank you. Thank you all.
And next up, still in Maynooth, we've got your colleague in Maynooth, Aman Jagwani, who is going to be talking about creative possibilities and customizability of live performance systems with open source programming platforms. So there you are. I'm just going to spotlight you so we can see you there. And I'm just going to remove the spotlight. Hold on one second. There we are. Yeah. Can you hear us okay and see us okay?
Yes. Hello, everyone. Am I clear?
You are. Yeah, perfectly clear.
Right. So I'll just share my screen. Okay. Is it visible?
Yeah, that's all good.
Okay. So hello, everyone. I'm going to talk about some creative possibilities and the customizability of live performance systems with open source programming platforms. There is a vast array of programming platforms available for audio and music and computer music in general, and such as C-Sound, Super Collider, Pure Data, etc. These are some of the platforms. These are used for different purposes like installations, compositions, generating source material for compositions, etc. I'm particularly in this project and this paper focusing on how live performance situations and live performance systems can be enhanced and customized by involving the artist in the manifestation of the live performance system itself. So I'm going to discuss a few different projects and examples based with made with this intention. But irrespective of the project, the point is to discover how being involved in creating this performance system impacts the performance for the performer and the audience as well. So just a few quick points about these platforms that I will discuss are when we are organizing a live performance, the tools available that are commercially available are to some degree generalized. The tools we use and our choices have some amount of customizability, but the tools itself are commercially produced and can be generalized. Whereas if we are making our own tools for performance, we can customize them to exactly what our needs are. And then the so I mentioned the extension of creative process into the manifestation of the performance system itself. And we can create tools and devices in a combination of hardware and software control. So it can be desktop-based platforms or embedded platforms that provide both of these areas of control over the performance system itself. So to start with just a discussion of a couple of desktop environments, the programming language or platform that I am focusing on is C-Sound. So in terms of desktop environments with C-Sound, there are various ways in which it can be incorporated into live performances. One of them is DAW VST plugins with C-Sound made in Cabbage by Rory Walsh. So we can create our own kinds of performance utility tools that things like MIDI controllers, or for example, I'm a percussion player, so I make triggering systems that trigger different parts of my system, like my drum performance can trigger different synthesizers and sequencers exactly the way I want to by using these VST plugins and hosting it in Ableton Live. We can also make custom sound generation instruments as well. And then there's also C-Sound can interface with other programming platforms and technologies. So for one example of that is C-Sound in Python. I'm going to elaborate a little bit more on this one. So C-Sound works in Python through the CT Sound module made by Francois Pinault. So this helps us combine the audio programming capabilities of C-Sound with features of Python, such as data science, prototyping, and in the case I'm going to present, it's particularly computer vision and machine learning. Yeah, so to demonstrate this, I made an example of hand tracking based real-time audio control of C-Sound in Python. So that uses the computer vision and media pipe modules in Python to track hand gestures, and then these are mapped to parameters in C-Sound such as pitch shifting, time scaling, and granular synthesis. The C-Sound audio engine can be run on a separate thread from the control, so that helps with real-time accuracy as well. Generally, projects with C-Sound in Python have been very useful for prototyping and been useful for creating different kinds of user interfaces. So this is another form of interface, but more in the sense of performance and real-time hand track control. So this can be manifested in the form of the performer controlling the sonic transformations with their hand tracking. But I've also used this in scenarios where the audience members are involved, because media pipe computer vision, you can also do entire body tracking. So people's movements past a camera have enabled them to be part of the performance as well. So I have a quick video that is like a few seconds long that will just demonstrate this. Was that audible? Was that okay?
Yeah.
Is he sharing the computer sound?
I'm not sure. Actually, are you sharing your computer sounds?
Yes, I am.
Yeah, it was a little bit on the low side, but I think it was audible. Are we okay? Yeah. I turned it up at this end in the middle, so yeah, it was fine. Thank you.
Okay. So the left to right movement was mapped to time stretching. The bottom to top movement was mapped to pitch shifting, and the opening and closing of the hands was mapped to granular synthesis, just the amount of granular synthesis in that. Yeah, so moving on to another example of this idea of customizing live performance systems. Now I'm moving to the embedded world. So in the paper, a few of the platforms that were discussed are the DAISY platform, the Bella platform, and an ongoing project related to FPGAs. So I'm going to elaborate a little more on the DAISY platform, particularly in combination with the Aurora DSP library by Professor Victor Lazzarini. There was a paper presentation for this as well on the first day. Yeah, so the DAISY platform is based around the STM32 microcontroller. It's a small board which contains useful peripherals for audio, MIDI, and sensor input and output. They provide support for programming with Pure Data, Max, MSP's Gen environment, and Arduino and C++. And they in terms of C++, they provide a DSP library called DAISY SP. However, there are only certain amounts of DSP functions available within the DAISY SP library. And for enhanced creativity and also for the modular approach that is possible, I used the Aurora library, which is the minimal, lightweight, header-only C++ audio synthesis and processing toolkit. So with this, you're able to include just the headers of different DSP objects that you would like to use. And that helps you create in a seemingly modular approach, the kind of sound synthesis or processing that you would like. So it's also the fact that it is lightweight and you use only the headers that you need is very good for embedded platforms, and the fact that you can optimize your resource utilization. So yeah, and then in terms of live performance, this helps if you're able to create an embedded device, your own instrument as such. It helps in customizing your sonic world of the performance to exactly the needs that you need that may not be available in a commercial product. So for this example, I've created a pitch shifter and variable delay multi-effect, kind of like a standalone system. And I was able to combine different variable delay effects in a way that I was not able to find like a pedal or something that I could buy. So that was very useful. There's an example soon. I'm going to show a video. And lastly, just to point out this, we are working also on adding support for C sound on Daisy and bare metal in general. So that will further extend the ability to customize and interact with this platform. So here's a quick video of the pitch shifter and delay multi-effect. Yeah, so the benefit of this is it's a combination of pitch shifting, flanging, feedback, all by using one delay header from Aurora library. So it gives you a very specific set of sonic transformation that I required in this particular case and did not consume too many resources for the small Daisy platform. Yeah, I will move on to talk about an ongoing project for creating such a platform for customizing your own devices on FPGAs. So FPGAs are field programmable gate arrays. They are a type of integrated circuit or a chip that contains an array of logic gates. So that the fact that, and these logic gates are programmable by the user or the programmer hardware engineer to be reconfigured to perform whatever specific task that they require. So it's essentially reprogrammable hardware. The way the array of logic gates is organized enables a lot of parallelization on the FPGAs and also allows a very high amount of throughput. So FPGAs basically I also run on very high clock rate. So all of these features of it result in ultra low latency, high throughput, and they also have a vast amount of general purpose inputs and outputs that enable all these factors make it very conducive to musical applications, because ultra low latency, high sampling rates, these enable things that are not possible on other platforms, such as higher order FM synthesis works with minimal aliasing and artifacts with higher sample rates. So that's a possibility. Multi-channel input and output to a very large extent with a bunch of channels is possible because of the inputs and outputs. And the feature I'm focusing on in this context is that FPGAs have hardware that is reconfigurable. So again, that aligns with the concept of customizing live performance setups for specific needs and situations. So yeah, but there is a disadvantage of using FPGA because they're very extremely complex to program and require specialized hardware knowledge. There is a form of programming this platform called high-level synthesis that provide higher-level access, but they're still fairly complex and require knowledge of hardware once again, but also require knowledge of a series of very specific vendor-supplied tools, which are quite comprehensive as well. So the goal with this project is to use HLS to create a library of pre-made HLS IP blocks. So IP is intellectual property. This is the name for modules within FPGA environment. So you can generate FPGA IP blocks from HLS that can then be programmed onto the device and interconnected with each other. So this project, the view is modeling a modular synthesizer with these HLS IP blocks. So each one you create, each module will have a specific function, like a module on a modular synthesizer. There'll be an envelope generator, oscillator, filters, etc. And then they're programmed and interconnected with each other onto the FPGA. So within this context, there is the possibility of modular sound synthesis on FPGAs. So this platform currently contains a base audio system for audio input and output, as well as control. Just getting audio out of the FPGA is also a fairly involved task, because the data types and the types of inter-module communication on hardware, and then converting it to digital audio and then to analog audio is a long process. So this platform provides this system where you have to just drop the modules that you want to use. And then there's a collection of IP blocks and modules that have been already made. There are oscillators, there's some filters, there is an envelope generator and a mixer as of now. We are working on adding more effects like delays, reverbs, etc. And then these can be interconnected and configured within each other to create different sound synthesis systems on hardware based on user requirements. So here's the good part is that they can be, like, with the same set of blocks, you can do FM synthesis, subtractive synthesis, additive synthesis, and then change it later for another performance, all within one chip. So that's quite powerful. So modern FPGAs are organized as systems on chips. So they contain a CPU section as well as the programmable hardware, the FPGA section of the chip. So the control system is being based on the CPU. This makes the control system modular as well, because from the CPU you can instantiate known protocols like MIDI or networking, or you can just have your own program that controls the synthesis generatively. So the programming flow of FPGA, just quickly, is with HLS is basically we define a function. It's called a top level function that is translated into a module with C or C++. Is the language that we use, but there are some specific data types and directives and programming methodologies that we have to use. So in this prototype of a function, we see this is a table lookup oscillator for FM synthesis. The arguments define the input and outputs of the module. So I have a frequency input, and then I use the HLS stream data type to transmit data between different modules. So that's an input for an envelope. Sorry. Then there's an input for a modulator signal, and then also the modulation index, and then we have the output. And then we give these directives that specify what kind of interface each port has, which is specific to hardware, inter-hardware communication. So just to identify, this is an AXIS is AXI stream, which is the kind of protocol that is being used for the output, the envelope, and the modulator signals. And AXI Lite is communication from the CPU part of the FPGA to the programmable hardware part. So basically this implies that the CPU is controlling the frequency of the oscillator as well as the modulation index. Yeah, so that's just a prototype of how you translate a function into a hardware module in terms of HLS. And then once you have your hardware modules generated by the HLS tool, they can be organized into a block diagram in another tool. I'm using the Xilinx environment. So this is a screenshot from Vivado, which is the block design tool available from Xilinx. So the ones with the little red, the squares in the middle are the HLS modules that are organized for this particular sound synthesis situation. And the other modules are other requirements like clock generators, I2X transmitter, which translates the AXI stream protocol into I2S data, which is then sent out of the audio codec for sound output. And basically other peripherals, but these are all already configured and supplied in the base audio system. Each of them need drivers. The drivers are also in the base audio system. So the goal is that all the user has to do is drop in their IP blocks and then create the sound synthesis system. And then this is just a quick example of FM synthesis on the FPGA. Just to note, there are some artifacts in the high frequency range. This is due to the board was being powered by USB from the computer. So that creates a little bit of artifacts due to irregular power supply. So just to play this. Yeah, so that was a quick example. I'll post the entire examples of all of these on my YouTube channel. Yeah, so that's kind of like a standalone system where the CPU is just generating a sequence of harmonic notes, and the FPGA part is playing them. It's running standalone as of now. It can be replaced by a MIDI keyboard or anything to control the frequency modulation index and anything like that. And yeah, so this is an ongoing project. It will hopefully result in a vast amount of creativity and ability to customize hardware devices with the potential of very highly involved synthesis, DSP that rely on low latency, high sampling rates, and other benefits of FPGAs. And then creating our own instruments and changing it from the same chip for different performances, different situations, provides a great amount of flexibility in terms of manifesting our live performance system. And yeah, that's it. Thank you. And thank you to Professor Victor Lazzarini for all the help with this project.
Thanks very much, Aman. And we've got time for questions. So any questions in the room or online? If you're online, maybe just put them in the chat window. There's lots more clapping still going on online. If you've got a question online, put it in the chat window, and then what we will do is we will come to you. If you've got a question in the room, please put up your hand. Any questions or indeed comments? Huge amount of promise in this area. So I suppose I'll ask a question just around what you have implemented in terms of the modular synthesis. Obviously, you've implemented FM, well, you've implemented some oscillators and filters and envelopes. So are there any particular challenges to other types of work, like where you start needing to work with larger memory size and stuff like that? Things like delay lines. Does that get Are there some behind the scenes challenges around working with FGPAs in terms of memory and things like that?
Yes, definitely. So FPGAs provide different memory locations. There's onboard on the programmable hardware part. There's the BRAM, which is very quick access, ultra low latency. So that is preferable, but it has limitations. So very long delay lines will not work there. So we will have to store delay lines in other locations. So the challenge would be managing the size of delay line we need versus the latency and the access of the delay line. And we need to prioritize one or the other for sure in those kind of situations.
Yeah, so that's a down the line one. Anyway, Alex, yeah.
Yeah, thanks for the presentation. I think you covered a lot of topics, right? A lot of different hardware frameworks, software environments, and so on, starting with C-Sound, talking about Aurora and stuff like that. And actually, I think Victor already sneak peeked a bit about the Daisy board, and you were mentioning it again. And when you had the little box where you demonstrated it in the video, I saw you had a Bella next to it, I think, in the video.
Yeah.
Yeah, I was wondering actually, because Bella is specifically good in terms of low latency. How is the latency with the Daisy board? What is your experience with that?
Yeah, the Daisy board is also pretty good. It depends on the vector size we're using as well. So Bella, I think, usually uses like a buffer size of like 8 samples, I think, if I'm not wrong. So in the one I was doing, the the example I showed, I was using a vector size of 4 samples, and that was possible because, yeah. So in that case, it was probably a little faster, but then there are limitations in how much also computational involvement there is. So then when you would probably need a larger buffer size. So I would say it's similar to Bella in my experience.
Right, and in terms of computational power, the Daisy board is more capable of doing or less? Do you compare that?
I would say it's less probably because it's much it's less, but then it's bare metal, so then there's no overhead of operating system. So then again, it kind of becomes a little similar in that context, that way.
Okay, thank you.
Okay, any other questions? Anything online?
Just
Victor, yeah.
No, just to complement like the sake as we got it compiled and running on the Daisy like just yesterday. What we don't have is a circuit to this, but we'll do that on Monday when we're back and Ian can lend us some breadboards and stuff.
Okay, very good. That's it.
I'm very curious.
Yeah, Alex. Yeah.
Keep me updated on that. Yeah, I'm very curious to see that because, like, I remember it was like 6 years ago that we did it with Bella, right? And it took some time to get it running.
Yeah, it took a while, but because the Bella has very specific Linux, needs, and this one has no like.
It's not
okay. Yeah, really.
Challenges, but I think
okay.
It would be nice also for the CSON conference maybe to hear more about that. Yeah. Yeah, that would be great. Thanks for them.
And the other thing is that the Daisy has other, like we're using the seed Daisy, which is the tiny thing, but there are other boards. Do you know any more about the boards whether they're better or they're worse or like the
so there is one. Basically, the other boards are more about how you are interacting with the Daisy. So there's one in the form of a Eurorack module. There's one in the form of a pedal. So that's the extension to other boards. But the actual processor and everything is the same.
Okay, so it is this one processing board, and then you plug it into these kind of interfaces, right?
Yeah, exactly.
Anything like that. Yeah.
Right.
Okay. And then you have to build the circuit around it. Like it has the DAC, ADC, and has all the GPIOs.
Yeah.
And stuff. But you wouldn't, if you want, then you need to put the circuit around it to work. Like you can build a Eurorack out of it.
Yeah.
Right.
Yeah. Excellent. Very good. Okay, so we do have time for one more question, if there is one more question that's brief. Otherwise, many thanks. Okay, Alex, go on. Go on, you will.
I find it great to have somebody who tried so many different environments because usually you have somebody who stick on whatever, just the Raspberry Pi or just on the Windows, and you seem to explore all the different things. And the other thing I'm always wondering about is like the AD or DA converter quality on these boards. So did you, because you were doing these FFT measurements with your frequency modulation and you looked into like signal to noise ratio. And because I'm not too happy with that on the Bela, for example, I find it a bit noisy sometimes. What would be your recommendation for sound quality?
Yeah, I mean, I have the same experience with the Bella. The sound quality of the output definitely has more noise than I would like. Yeah, I mean, these are limitations of the boards because there's only so much they can put on it. Even the FPGA board we are using has a SSM2603 audio codec by Analog Devices, which is pretty good. But then if you're doing something like high sampling rate, is not going to work because it's limited in that way, and also has a decent amount of noise. So I mean, the recommendation, I guess, would be to have an external audio codec based on your needs and just connect it to the board. Yeah, exactly. Yeah.
Right, but because if you're following up on that research, this might be a really interesting paper to really look into like the sound quality of these things.
Definitely, yeah.
There's another thing about FPGA is that you might just write the whole DAC code in the FPGA and don't just get the data up as analog. Basically, you have to put the filter in, but it's pretty
exactly
much,
yeah.
So this is another thing we've done. We have done with Sean and the Pulse team. So we did a collaboration with them where we're looking at actually doing the writing code for the DAC, and so that all you need is basically two things out from the PGA and then a very, very simple low pass filter, and then you get the sound coming out there. So and then the quality is controlled by the code.
It's true, but then there's a number of dithering and oversampling.
No, this is run like at megahertz and things. So that's the whole AOGscript. That's about.
Oh, but on the FPGA, you're running
it's a real. That's the advantage. You can run like a stratospheric something rates.
Okay,
and that's why you only need a very simple, basically a simple RC filter at the other end, to smooth it. But Elijah doesn't exist in that.
Right. But yeah, that's an interesting topic also to follow on. Yeah.
Definitely.
I'll be curious to read more about that. Thanks.
Yeah, excellent. So many thanks. I'd also like to thank all the presenters today and everyone who's contributed. It's been a great session. So many thanks to everyone. Okay, we're going to take a quick, just less than half an hour break. We're going to be back at 12 noon UTC, GMT, all of that. And it's with the panel reflecting on current challenges designing digital audiovisual composition tools to support creative practices. That's going to be here online and here in the room MI022. That's going to be convened by Dr. Nuno Otero from the University of Greenwich, UK. So we'll be back in just under half an hour. Many thanks, everyone.